All right. Hi, everyone. Thank you for being here for the TEAMER TPL Assessment Workshop. We are going to go ahead and get started, and we'll just hopefully people will join us as they can. Just to let you know, we are recording this workshop, and it will be available on our web page once we're done. Give us a couple days, and so we'll go ahead and get started. So my name is Samantha Quinn. I am the program director at Pacific Ocean Energy Trust. We are the directors for the TEAMER program. And I am just going to give you a couple of updates of what's coming up for TEAMER before I hand it over to Dominic Forbush. Maybe. Okay, so just as a reminder, we do have our FTS 12 closing March 1st, 2024. So about 6 weeks away, which is fairly crazy that we're already halfway through January. And then we have our next workshop coming up on April 8th, 2024. And that is how to write a successful TEAMER application. This will be another webinar. It's meant for both facilities and applicants to kind of walk through the application and get a little bit more information about what we're looking for as far as when we do our reviews for the application. So this is particularly good for first-time applicants as well as for people who have applied and not been successful so far. One thing about TEAMER is that we do really encourage people to continue to apply based off of the reviews and comments that we provide back to people. So if that's kind of where you're sitting, then we really encourage you to join that that webinar. And then finally, we will also be hosting an in-person WEC modeling and controls workshop at Oregon State later in the year. In May, that will be limited to, I think, 50 participants, maybe less, and we will be having applications for that. So we will be releasing more information about that in the coming weeks, so be on the lookout for that. And with that, I hand it over to Dom. Oh, I guess one other thing, sorry. We are going to, if you have a question, feel free to put it in the Q&A. We will have Q&A at the end of Dom's presentation. And you can, at that point, you can also raise your hand as well to ask a question and we can unmute you. Okay, thanks.
Hey, can you enable screen sharing for me, please? It's not.
You should. I just closed mine, so you should be able to now.
Okay. All right. I think hopefully you all can see a screen. Yep.
Yes.
Okay. Does it still look okay for you? Because I'm in presenter view now.
Yeah, looks good. Thanks.
Awesome. All right. I'm Dominic Forbush with Sandia National Laboratories. Thanks for coming to the TEAMER webinar today on the TPL assessment facility. I've been working on the TPL project for about 5 years from the time I joined Sandia as a postdoc. And in that time, we've made a lot of progress and had a lot of growth. So I'm excited to share some of that with you all today. Bit of background to start out. The TPL stands for the Technology Performance Level. It's intended to be an orthogonal metric to the probably more familiar Technology Readiness Level. And while TRL on the left there is sort of solely concerned with where a technology is in its development process, does it exist solely as a concept? Does it exist as a prototype? Or is it something that's been tried and tested and field deployed? The TPL is concerned solely with the potential commercial performance of a technology, regardless of where it's at on the TRL scale. So you might expect or you might hope that a device that is anticipated to perform poorly might never make it to a high TRL level but that's not the case. And in fact, but we would like to try to anticipate any problems we would have with commercial success while we're at a fairly low stage on the TRL level. And the reason for that is when you're still iterating at small scale or as a concept or in computer models, it's really cheap and can be very fast to iterate. In contrast, if you're at a high TRL and you're changing out hardware or deployment strategies, or you have a lot of inertia and mass associated with this design, both literally and figuratively, it can be very expensive to go back and do a redesign. So kind of the ideal application of the technology performance level assessment tool, which we'll be talking about most of this presentation, is at a low TRL so that you can proactively address all of these potential performance risks at a really early stage, and you have a night so you can do a lot of your iteration and redesign at as low of a TRL as possible and keep that inception to market overall cost as low as possible and its time as efficient as possible. That said, it's something that's useful to do at just about any TRL level. And you can see a black trace there, the T3, that sort of represents a hypothetical case in which somebody is approaching a high TRL technology and perhaps informed by a TPL assessment, they opt for kind of going back to the drawing board on a few components and squaring those up before they move to a high TRL. A bit of history here. The TPL assessment is based on a really involved systems engineering report that was informed by a broad swath of stakeholder requirements for commercially successful wave energy converters at the grid scale. And that was what the original assessment was intended to be. Here's a graphic from one of those reports, and you can see that it was a broad swath of stakeholders that continued or that were considered. And I don't think that's even an exhaustive list. And the job of the systems engineering report was to define the capabilities of a wave energy system from these stakeholder requirements, and capabilities in this case being what the system needs to be, and then define a set of functions which are what the system needs to do to achieve these capabilities, and iterating that until those are well aligned. And then through a variety of systems engineering tools, kind of mapping how those functions relate to each other, if there's any perhaps hierarchies in the fulfillment of these functions, which ones are more critical, which ones affect others, and all of the subtleties of systems engineering there. And this was all completed back in 2016, 2017. We have a lot of contemporary work that continues. These are living documents. We continue to work on them and iterate them and carry out assessments for different technology developers. And we've also started looking at moving into other markets and other technologies besides the grid scale wave energy converter market. We're looking at emerging markets like those in the powering the blue economy and other marine energy devices like current energy converters as well. And if you follow that link down at the bottom of the screen, you can go to a public-facing version of the utility scale wave energy converter assessment. You just follow it one level down, and you'll be at this screen with me. And this is an example of what the contemporary assessment looks like. Here you have a variety of capability areas, all of which have some scores assigned to them. Here I think it's random. I'm pretty sure I just clicked random numbers to make this screenshot. But the TPL tool itself is fundamentally a survey. So you have a question, and actually a lot of questions like this. You'll have a question guidance that kind of frames the context of the question. Maybe it defines terms or tries to make the question as clear as possible to someone who's completing it. And then you'll have some scoring guidance. Here I've just broken it out so it can all fit neatly on one screen. And your job as the assessor, or you'll be working with an assessor to select a score from 1 to 9, 1 being bad, 9 being great, and a confidence level. That is, how confident are you? How sure are you of that score? And also logging some justification, keeping track of why that is your answer. Thinking about how this assessment tool is used, a couple of really big picture points to make. While the ultimate scoring roll-up and the the final value of TPL. A lot of work has gone into that in the background to make sure that that's meaningful and robust and repeatable as it can be. The true value of going through this is completing the process. It's the learning that you get from putting all the information together to be able to answer these questions. And the output, ultimately, that scoring roll-up, is not as useful as it could be, certainly, without the context from that process. A couple of other points here is that the tool is fundamentally a technology assessment. We attempt to be site and application agnostic. So we're not evaluating the technology, the pairing of a particular wave energy converter or marine energy device in a particular site for a particular purpose. We're trying to, as best as we can, assess the merits of the developer technology, be it in this case a marine energy system, in isolation of these other externalities. And the final point here is that from 2016 to now, and we would anticipate and hope continuing into the future, a lot of lessons continue to be learned by the wave energy and the marine energy industry. And it's important that for these tools to continue to be useful, that we view them as living documents and we continuously integrate the best practices, knowledge, and standards as they become available into these tools. So if you've completed an assessment, 3 or 4 years ago, there will certainly be a lot of commonalities between the assessment, that one and the assessment that exists today. But there will be some novel and new areas as well. And that's all reflective of the learning and the iterations that we continue to put into these tools. So as technology assessors, we consider ourselves somewhat of an expert in this space, but because we're assessing novel technologies, you might ask, well, how do we go about foreseeing and properly rewarding innovation that we haven't thought of yet, or is really novel to the industry? And that's done by posing a series of questions that might at first glance appear to be contradictory. And I've posted a deliberately weak example here because it's going to segue hopefully into my point nicely. But by reading the first question, you might assume if you score highly here, you'll necessarily score low on the second. And looking at these questions related to a WEC subsystem designed for all of the loads of the ocean, you might think that if that's the case, if you can survive everything the ocean might throw at you, well, you'll likely score low on the right-hand side question, which is, what's the ultimate cost of the device? And as I'm sure you're aware, this has been solved in a variety of ways by a lot of different developers. Maybe it's a survival strategy or some clever use of materials that allows them to score highly in both of these areas. And this is just one example of things that are in the assessment, but these apparent contradictions allow an innovative solution to score highly on both questions, whereas kind of a common design problem in the industry might force a high score in one and a low score on the other. Thinking about how the assessment is broken down, we're starting to branch out from the grid scale WEC assessment shown there on the far left. We've got that for current energy converters too. And we have various powering the blue economy markets in varying states of development. We've got wave power desalination on top, isolated microgrid to the right, and ocean observation on the bottom. I won't say too much about those in detail. All that to say, if that's your intended application space, we might still be able to support you either now or in the near future. The way that we're able to do this is sort of an abbreviated stakeholder engagement and systems engineering approach that we're allowed to contract in time because we recognize that these are marine energy systems fundamentally. So they share a lot of functional overlap between these application spaces, even though there are certainly a lot of unique characteristics that need to be had in each space. So what would a TPL assessment look like for you coming into the TEAMER program? We envision it being a first and or third person assessment. So either we support you in carrying out the assessment yourself for your own technology, or you provide us all of the information you can, and then we carry out the assessment on your behalf and in communication with you. Again, the process here is really has a lot of innate value, just putting all of the information together to attempt to answer this really holistic set of questions and assessment tool. And I think the value of iteration, either within a TEAMER award or on your own through time, creating a snapshot of your technology through a given assessment, and then iterating that assessment. Maybe you've driven down your uncertainty, maybe you've improved your design in certain areas that you identified as weak, and seeing how the anticipated performance of your device increases through the identification and addressing of these assessment identified high impact areas for research and development for your device. What we would need from you to do this is as thorough of a description of your device as you have available. This can be quantitative, it can also be qualitative, depending on what you have available at the time. But it's also important for us to understand how you know what you know. What aspects of your device are set in stone? How have you arrived at your cost estimates, your performance estimates, things of that nature? And along the way, if you've made any key design decisions, moved one direction over another, understanding the rationale for that can be really helpful for us as assessors to understand the evolution of your device in its own context and potentially in the context of the assessment tool. That said, obviously, there's probably going to be some sensitive information related to that. That can all be creative protected, and we can work with you and work with TEAMER to still release a publicly available version of this final report that is useful to the general public, but we can normalize or abstract anything specific or considered sensitive by a developer to protect your intellectual property throughout this process. A couple of examples of what the output will look like, what you get from us at the end of this. You'll go through either us with you or you on your own with our support, and we'll go through and answer a series of questions that look a lot like this, a question and scoring guidance throughout all of these capability areas. And you'll end up with a score output that looks like that on the right. It's a kind of an average score, and then a range to the left and right of that estimated by the uncertainty that you've specified for a given score. And so in this way, we can identify capabilities and subcapabilities and even finer subdivisions than that, if we need to, of where we anticipate your performance might be lower than you would like. We can identify areas where you have a high amount of uncertainty and you're not really, it might be worth doing some research to figure out where within the anticipated range you are. And this is the exact same information conveyed graphically. The only addition here is kind of that red zone, which is a stakeholder identified region where you don't really want your scores to fall in this region, or you might have a problem. Again, I think this is made up numbers here, or it's one of the reference model devices. So this particular person doesn't need to be concerned because it's probably made up, but those two dope bullets there on permitting and environment and safety and function, we really would like those to be outside of the red. And as I mentioned before, to quote myself from 4 slides ago, these outputs are great, but in isolation, they are not as useful as they could be without the context and the understanding that you've gained going through this process. And so a really rigorous documenting of that with a discussion of findings, a justification for all of the scores and the approximations that were made along the way, as well as, I think, possibly most significantly, the key findings and the suggestions for a path forward based on the results of this assessment. So I anticipate the question or concern that, well, hey, I'm at a really low TRL, or just have a prototype, or maybe just a concept at this phase. What if I can't make it all the way through the assessment? And that's a very fair question. It's an outcome that we've seen in our own work quite a bit. And this slide, I think, is trying to drive at the point that there's a lot of potential off-ramps along the way here through this TEAMER award, where you don't necessarily have to complete the assessment to still arrive at a useful result. And that's a useful and specific research direction. And in communication with you early on in planning the TEAMER award, we'll probably be able to anticipate, where specifically along this vertical axis our project is likely to lie. And we can work with you, and perhaps in one project you can iterate and move farther and farther down this axis. But the point is, you don't have to complete the assessment in full. You don't have to have a detailed answer to every question to still get a lot of value out of going through this process, and to still get some really concrete and useful suggestions out of it. I think a lot of similar information conveyed there, but I guess the only additional point is there, of course, is benefit to completing the assessment, because the more detail that we're able to work at together and to get at with your device, the more specific and structured this direction and proposed research path or proposed changes to the design can be. We can move from anything from kind of conceptual suggestions all the way down to the nuts and bolts, and those latter suggestions are going to occur basically the farther you can get down through the TPL assessment. And this is not the point of the TPL assessment, but because we're all operating within the TEAMER architecture here, on the left are questions that you'll find in at least a previous version of the TEAMER application. I suggest there's some very similar versions in there this round as well. And all of these questions are going to be very well informed by completing a TPL assessment or attempting to work your way through one. If the TEAMER application were a test, the TPL assessment would be a fantastic way to study for that test. And hopefully it will, aside from this application, will frame some potentially really high impact areas of research for you in the near future. I'm going to take the last few minutes of my presentation to talk through an example. This was done within a collaboration with the Marine Energy Alliance, which is a predominantly European group of marine energy developers. 4 technologies went through this exercise. This was back in the late 2010s, I think early 2020s, when we started to have some results. And we're going to talk through one of the project partners for this, and we can see how the TPL assessment was applied in this particular case. The technology we're looking at here is the KN swing. It's the size of a large vessel. It's essentially a floating platform with an array of identically sized oscillating water columns built into this large floating structure. Some of the assessments and some of the quantitative values that we used throughout the assessment are shown there in the middle. You don't really need to remember any details of this, otherwise to say that this is a grid scale device and it is intended to be quite large structurally. The dimension there on the low axis of the figure is 20 meters across at the in draft. So this project, a lot of information was provided and we were able to put it through the TPL assessment process. We won't talk through all of the details here, just present 5 of the key results. The first thing that came out of the assessment is that structural weight here accounted for 70% of the cost of this particular WEC. And if you're a developer who finds yourself in a similar boat, don't worry, that's not necessarily a problem for you. But in the context of this particular device, that was felt to be exorbitant. To support this really large and expensive structure, it was found that the mooring lines, their maintenance, inspection, replacement as needed, accounted for what was considered to be a disproportionately large portion of their operating expenditures. So a potentially high impact area was suggested, and that was to study and review this mooring strategy, perhaps as a different material or mooring configuration that might be more well suited and drive that OPEX down. Third suggestion here was to use a fewer number of larger oscillating water columns to increase the capture width ratio. And the fact that such a large swing in design resulted in such a substantial change in performance suggests that maybe there wasn't the level of optimization work that that could have been done to achieve a really high performing device. And so that was an area that was identified as potentially high impact research, as well as to do a really systematic optimization study of the shape and distribution of these oscillating water columns within the floating structure. The last 2, at the time the study was conducted, it was using a fairly low efficiency air turbine. And those were highlighted as potentially really high return on investment areas to work with developers to try to find a more efficient solution for the power takeoff there. And the fifth area was the potential impact of water hitting the ceiling of the air chambers. These are semi-rectangular air chambers. And this was identified as a potentially really high risk and potentially really high unknown. At the time, there wasn't a detailed level of analysis put into this to understand what these extreme loads might really look like and to really inform, as well as could have been done, the structural design of those elements. And so another high impact area of research that was suggested here was to do this involved CFD work to quantify what exactly the risk was here and what exactly these loads might be. That's the last content slide I have. Thank you very much for listening here. Just quick reminders, the RFTS 12 applications, as Samantha said at the beginning, are due March 1st. Questions related to TPL, you can feel free to send to me. And if I can't answer them, I can route them to the appropriate person. And the TEAMER application website is there at the lower link. Thanks everybody for listening, and I look forward to your questions.
Great, thanks, Dom. We do have a couple of questions in the Q&A. The first one is, in physical model testing, how is it proposed to overcome the limitation of measuring power performance, as power performance is incorrectly assessed at reduced scale, and hence there is no easy way to move forward the TPL at this stage?
All right. So that's a really good question, and it kind of gets to the level of uncertainty of the results that, or the answers to the TPL questions. Obviously, there's a lot related to the anticipated power performance of the device, and I think the question is, I'll rephrase it for my own benefit too, is how reflective of the anticipated full-scale performance can we be if we're informing these power performance estimates on small-scale tank tests? And I agree, it's really challenging, and I think it's something that we don't address directly in the TPL assessment, beyond to say that a small-scale test may not perfectly inform those results, and it still might be worth doing potentially simulations at higher scale, or some sort of scale correction, even though they can be a bit dubious, to think about what that uncertainty actually looks like. And I invite other colleagues to jump in on that point as well.
And Pedro, I did unmute you if you want to expand further on your question or anything.
Yes. Thank you, Sam. Thank you, Dominic. Great presentation. I was more thinking on the plot or the slide where you have the TEAMER flow chart. And if we are supporting the developers, sometimes we have, more than sometimes, it's actually very common that we have questions or requests from clients, specifically assuming that we are going to be able to answer this question, is how can we, or what is the performance? They are assuming that they have a power performance that is this level, and they want to show that actually their system works in a certain level. And I try to educate them and try to make them understand that the reduced scale is not really answering the question, but sometimes is not enough. So I was hoping to see in this process of TPL showing that the route is not yet at the stage, or as you said, I think the answer of uncertainty is great, because that gives us the point, the starting point to discuss with the clients in those cases.
Yeah, thank you, Pedro. I hope I pulled up the slide you were referring to. Yeah, I think we often find ourselves in a similar position of trying to explain the difficulty of scaling tank results to full scale results, especially in the context of electrical power. And that's a a risk that we would identify. It's an uncertainty that we would recognize and potentially suggest some pathways forward to reach a resolution that might be device specific. But with respect to like a general answer to that question, that's beyond our scope.
Thank you, Dominic.
Am I just come in there, Dom?
Yes, go ahead.
Yeah, thanks a lot, Dom. Excellent. Yeah, I just want to add to the question that the TPL assessment is meant to be looking at the cost and performance drivers that make up eventually the techno-economic performance potential. So several of the aspects that are being considered would not come out of a tank test anyway. It's a purely hydrodynamic experiment. It may not have the controls. It doesn't have the power conversion. And so it's the power conversion from, the first stage after hydrodynamic to the next one and to electrical. So even without a tank test, one could say, let's do a TPL assessment, look at the cost and performance drivers. Maybe one looks at the degrees of freedom that are being operating, at the type of technology, at the portion of acting surfaces in relation to non-active surfaces even. So I want to just give examples to cost and performance drivers that will make up the eventual numbers in the future when these are known from exact measurements and from experience and from even prototype testing. So the tricky thing is the forecast or the estimation of the future. Yeah. And because we don't have the numbers, really. That's it. Yeah. Thank you.
Okay. Pedro, did you have any other questions with that?
No, that was great. Thank you.
Great, thank you. The next question we have is, what is the availability of a TPL assessment for a tidal turbine developer? Can it be the topic of a TEAMER application? I can answer the second part of that, which is absolutely, that's part of the reason why we are having this workshop, is that we want to make it better known that TPL assessment is one of the capabilities within NREL and Sandia's facilities. So yes, absolutely. We urge people, especially those who have yet to be successful with their TEAMER applications, that this might possibly be a route to take instead of, well, they would have to apply through TEAMER to go through a TPL assessment, but that it might be a good route to take before they go on to other types of testing. So Dom, you can answer the other part, please.
Yeah, the answer on the other part is it kind of depends on your intended application. If you're looking for grid scale, utility scale power development, then that assessment for KEX is done. We'd be ready to do it today. And that's a really strong assessment, a really well-informed assessment. We also have one that's at a very high state of completion for an isolated microgrid application. We're still working on pulling in the last of the stakeholder feedback for that, but that's something that in the near term, it will be available as well.
And then the other part of the question, or another question that stemmed off of that, is how much does it cost?
Is that for me? Yeah, so I guess it really depends on, this is a convenient slide to have had up, on how far down we get here. And that's something that we could kind of suss out in conversation with the individual applicant, is what exactly is your objective here, to understand how far down this we really need to get, how many times through the loop we should go. I mean, spitballing numbers, I would say, I don't know if I should spitball numbers, Sam. Stop me if I'm overstepping here.
Jesse, I think you want to jump in.
No, I was going to spitball numbers, but because I think it's safe enough to, it'll have to be kind of worked out per entity and per kind of scope of the effort. But I mean, it could be as simple, like if we're going across the top line here, as maybe a $25,000 effort. And I know I'm going low, but that a lot of that has to do with the availability of staff, which staff, because not all staff cost the same. And then the expediency is aligned with availability, but both the lab availability and the TSR's ability to kind of get the information to us and work with us on that. So, and then it could be much more than that too. It could easily be double that. It could be $50,000 and to kind of go through and categorize and classify all that information with somebody. But that's the ballpark.
Great, thanks. And yeah, I mean, again, if you're asking for this or applying for a TPL assessment through the TEAMER program, then that is something that we would obviously pay for that support. And as long as it's within the cap of the TEAMER program, then it would be no problem. George, I see that you have your hand up.
Yeah, I just wanted to say thank you. You're definitely answering my question. I was it's a new thought to me as to you know, it being available. So I just wanted to make sure that it was something that I could potentially apply for if I want. Yeah, thank you.
Yes, absolutely. Thank you. Does anyone have any other questions? If you want to raise your hand, I can unmute you. Not, or you can put it in the chat or the Q&A. Oh, there we go. Matt, you should be able to ask your question.
Thanks, Sam. Hi, everyone. Matt Sanders here, formerly of TEAMER, currently with Gallagher Insurance. I think this is a useful tool for documenting work completed stages for insurers. I think some of the challenges we see are in verification of technologies and things like that. So while this won't obviously cover everything, I think it's really helpful documenting the stages of work done and having kind of professional third-party assessment of technologies. So just wanted to throw that out there. And hi, everybody.
Hi, Matt. Thanks for chiming in. Yeah, we do have a capability area that drives down or tries to drill down the risk of investment, the insurability of devices. I'm sure you're a lot more knowledgeable than we are in that particular space, but we do attempt to address that in the assessment tool.
Thanks, Matt. Joachim, I see that you have your hand up.
Yeah, thank you. Matt, thank you as well for this. So maybe I just want to add, because of this idea of insurance and so on, we've done assessments now for leading technology developers in terms of leading, I would say, certainly TRL and absolutely also the companies that are currently in the water globally. And the reason why they approached us was they said, hey, you know, the stuff that you're asking there in this assessment is actually stuff that our investors want to know. So giving a response to that has been extremely valuable for them. And previously, I have a question for the participants here. How do you currently go about identifying what the greatest risk for failure is in your technology development? It'd be great if somebody could come in and share that. I'm aware of all the names. I don't know if developers are around.
I didn't hear what you said, Samantha.
Oh, I was just going to say, if anyone wants to answer the question, I see somebody's raised their hand now. Oh, George. You should be able to talk, George, if you just unmute.
George, we see your hand. Maybe is it a
Okay, is that better? Can you hear me? Yeah. It's sort of it's almost like seat of the pants. It's like you look at I've read a lot of articles and I see turbines go in the water and and the blades are bent or something like that. You know, I mean, it's there. I don't have a formal way of assessing that. I am familiar with FMEA, failure modes and effects analysis, from my previous work in manufacturing, and I don't think I've applied that formally to my to my tidal turbine development.
Yeah.
But it's a really interesting possibility to me to have a third party evaluation, and I'm at the stage now where I'm kind of happy with what I think I know about my product and development, and I'm interested in seeking investors, and it seems like it would be very helpful to have third party evaluation, to bring to a potential investor.
Great, thank you for that insight. Thanks. Two thoughts to this. You were referring to risk assessment. Typically, risk assessments deal with what could go catastrophically wrong or would be failure in technology. And it to a lesser degree deals with its potential to be failing on the techno-economic side. So, and this is both wrapped up into the TPL assessment.
Yep.
And we often refer to one key purpose of the TPL assessment to be assessing the robustness against failure rather than the numerical precision on how good something is. So it's more covering the ground so we don't fall through any holes, rather than knowing exactly the tip of the mountain that we can climb. So, that also in relation to risk. Thank you.
Yep. Thank you.
And
There's
Wes
another
should be.
Hello, Wes here. So I would echo that for us, we typically look at those single point of failures where there's going to be something catastrophic, like you said, where you're losing a device, you lose operability. On the techno-economic side, it's probably a healthy respect for what we don't know, where if there's a change in permitting or accessibility, is there something as far as the deployability that's going to change some of our assumptions on, in our case, what the levelized cost of water is, what the maintenance interval is going to be. Those are where we have the most, I guess, question marks or concerns on the failure side.
Great, thank you. Thanks. Maybe another aspect in terms of this thinking, if we don't go as dramatic as failures and the risks, it's also, apart from looking at the final result, will it be techno-economically viable? It's also about what is the next step. Say I'm somewhere in my, TRL, TPL map at TRL 3 and TPL, well, probably maybe 4. The question is, and I get some funding. I write an application for 4, I get some funding. What do I do with it? Do I run another numerical model? Do I change control? Do I maybe have an O&M plan? What could bring the best benefit to the desired trajectory on that map, so that we are moving forward at low cost, time, and risk, with the maximum, benefit from any activity that we're doing. So it's also the short-term orientation and how we are moving around. Okay.
Yeah, to follow up on that, that's the point I was going to make, was that we've talked about third-party assessments, which are super valuable, and we've talked about all the reasons why that would be good. But and this kind of would getting back into the cost question, we actually use this ourselves in our own kind of innovation inside the labs, where we do an assessment, a TPL assessment of our own kind of ideas and concepts and such, so that we can identify areas that we think are the most valuable to improve. And Dom showed the kind of one about you can have a positive score in one area, not that the score is really what's important, but you could do well in one and not in the other. And that essentially is identifying a contradiction or a potential pathway for improvement of your device, whether that's a very innovative pathway or just a more design kind of approach, that it's just an area of focus that should be studied. And so we use it that way. And we would want to, as depending on what you would want, honestly, you would be driving the request here, but we would want, that's how we use it. And we'd want you to be able to use TPL by yourselves. We'd certainly introduce you to it, and we can train you up on how to use it. And then you can use it on your own. You can come back for further assistance if that's what you need, if there's more questions, but it would be a living a tool in your toolbox to use after a given TEAMER award, for example.
That's great, Jesse. Yeah, I think I've sat in a couple of different like presentations or demonstrations of TPL assessment, and it just seems that the questions alone that are asked within the assessment are super helpful to the developer. And so hopefully, I think what you're saying too is that once you start to learn how it's used and what those questions are getting at, that it'll continue to be of use to you, which is great.
Yep.
Any quick questions?
Only a second.
Go ahead, Jakob.
Okay, I mean, I don't want to take up time. I want to fill a void. Another question for the attendants. How do you currently identify the TRL where you are in your technology development? And what kind of definition of that do you use?
And
George?
and Joachim, when you say that, are you meaning that are folks using a more generic descriptor or a maybe marine energy based or very specified TRL?
Whatever it may be, I think it's probably all over the place and different definitions. Yeah. Thanks.
This is George again. I can answer that because I recently went through the process for a National Science Foundation application that I've just submitted. And I just looked online and I found one that looked like it was the sort of a standard the NASA definition, and I just did a plug and play. I just tried to answer the questions and figured out where I would stand on that. I don't think I really know if I did it right, but that's what I did.
Okay, great, thank you.
Landon, you should be able to talk.
Landon? Oh yeah.
But we can't hear you.
So Wes here, similar to George, we look at probably the NASA definition, and if we have simulations and then a concept, that's probably 3 in our book. If we've got something that's scale, that's 4. If it's something that's in a proper wave tank or in the ocean, that's 5. Is kind of how we've been going.
Okay, thank you. Yeah. Landon? You seem to be unmuted, not muted again. Maybe you can type if you're speaking and we can't hear you in the chat. Maybe I'll fill the gap just for a minute. And I just want to say, so the question, is kind of provoking 2 thoughts. How does the accuracy, because we often ask about the accuracy of the score, how does the accuracy of the TRL assessment, no, I shouldn't say that, the TRL definition and identifying where we are compared to what we are trying to do with TPL. And also, the entire notion about thinking about accuracy, how valid is it in those 2 domains? And the other thing I wanted to mention, there are very different definitions around. There's a European definition, there's a DOE definition, the NASA definition more general. Then it's already 12 years old, but a beautiful definition for wave energy, particularly from the Irish Electricity Supply Board. That's what they were called at the time, which from TRL 3 on has a whole page of definitions of what is expected to have been done. Not how good it comes out, but what has been done. And the last thought, we've been debating internally because we're moving on in the level of detail with our TPL assessment. We're extending scope. So the question came up, maybe we should refresh and purposely more detailed, define in more detail what we think the appropriate TRL definitions are. So that came up as a question, and if you have an opinion on if the team should be looking at that, then feedback would be valuable too. Dom, you unmuted.
No, I wasn't actually going to remark on that. Sorry, I did that by accident.
Okay, Landon, can everyone see the Q&A? Landon said, I was only going to reference that for funding and reporting purposes, we are generally required to stay within the DOE TRL assessment, but I completely agree that there is variability within that. And sorry for the audio issues. Wes, you should be able to talk.
Awesome. Yeah, I was going to say that as an alternative to TRL, one thing that I've enjoyed taking a look at is, I guess, OES out of Europe, looking at the technology stages. That's been helpful for identifying what you should be working on in stage 0, stage 1, stage 2, and then moving towards the next stage. Similar, it maps closely to TRL, but yeah, it's been a good attention directing tool.
Yeah, thank you. Yes. Originates out of the Hydraulics and Maritime Research Center. I used to be there for a long time ago.
Great. Well, if there aren't any more questions, I just want to thank the TRL or TPL, sorry, assessment team for putting this together. And if anyone on the line has any questions, feel free to reach out to Dom or to reach out to myself, and I can put you in touch with the TPL team. And yeah, we will be having our next workshop April 8th, so we'd love for you to join us then. Cool, and Dom just put his email in the chat, so you have it there. And yeah, feel free to reach out if you guys have any questions for us. Thanks for coming.
Yeah, thanks a lot for your time, and particularly for the vocal dialogue and exchange. And thanks a lot, Dom. Excellent presentation.
Thank you all. Thanks for coming.
Yep. Thanks, everybody. Really appreciate it. Thank you, Dom.